So I called this unit 6A instead of just 6 because there is also a part 2, but that won't be until after winter break. So when we come back from break, we'll start working on covalent bonding and naming. So for now, it's just ionic bonding. And I know we haven't done a lot with different compounds. So as a refresher for you, when we see something that is ionic, that's the type of compound that we call a formula unit. So if that word formula unit looks familiar, that is because back in Unit 2 and Unit 2.5, when we talked about moles and converting moles to particles, a formula unit is a type of particle that we were using. And then formula unit is what we abbreviated as FUN. And then its counterpart, when you had a covalent bond, that was called a molecule, which we abbreviated as MC. Does that sound a little bit familiar? Hopefully a little bit. Okay. So that will come up again in second semester, but for now, this entire packet is all about formula units, and we'll kind of get into why. So first, we're starting with a review. Why do atoms bond? What is the whole purpose of bonding? To become more something. I heard it. Stable. Thank you. To become more stable. We've written that in, I don't know, 4 notes packets now, so hopefully it at least is like sounding familiar. So atoms bond to become more stable, and what makes an atom stable? Full valence shell. Perfect. So the goal of every single atom on your periodic table is to become more stable. The only elements on your periodic table that are already stable are your noble gases, because those are the ones that have a full valence shell. Every single other element on your periodic table is trying to become stable, trying to look like a noble gas, but which one they want to look like depends on where they are. Most atoms need how many valence electrons? 8. So for the most part, atoms need 8 valence electrons, except for our energy level 1 elements, so things in the very first period, the first row on your periodic table. So that would be hydrogen and helium. Those are special because energy level 1 can only hold a maximum of how many electrons? 2. So they still want to be full, but full for them means 2 valence electrons. Stumbling over my words a little bit, sorry. Let that adjust. Maybe. All right, and then letter B says, what is the octet rule? We've also learned this one already. This says that atoms will blank, blank, or blank valence electrons. Gain, lose. Okay, I like those. Gain, lose, or the last one is share. Perfect. So I'm going to say gain, lose, or share valence electrons in order to have 8. So they're full shell, although sometimes that's 2. The reason that I wrote share in a different color is because when you are sharing valence electrons, that's what makes something a molecule. That's a covalent compound. So again, that won't happen in this unit. In this unit, all we're going to talk about is gaining and losing electrons. So part 6B of our notes, we'll talk about covalent compounds and how molecules are formed. And then for the rest of these, I'm going to intentionally color code our cations and anions so that we can kind of keep them straight. If you want to follow along in color, that's perfectly fine. So, as a reminder, your cations. If you are a cation, remember cats have paws, so a cation is positively charged. How did it get that way? What had to happen for the cation to become positively charged? it had to lose electrons. So when it loses electrons, that means that if it starts out as a neutral atom, where our protons equal our electrons, that is a neutral charge, but losing electrons means we have an imbalance where we have more positive charges, more protons. And then the other side of this is going to be an anion, which is a negative charge. And they get negative charges by, gaining electrons. This gets confusing for students because if we're talking about gaining things, students typically want to write a positive sign, but that's not what's happening. So remember that gaining something negative, gaining a negative particle like an electron, makes you more negative. This next section talks about ionic bonding. So this is our brand new kind of focus, is when we are gaining or losing electrons, those electrons have to come from somewhere or they have to go to somewhere. They're not just appearing out of thin air, they're not disappearing. So bonding is what's actually going on. This occurs generally between a metal and a nonmetal. So for my metal, I'm going to use that same color as my positive cation. So the reason I wrote this in that color is because your metal will have a positive charge, which according to our periodic table and what we've already covered should make sense. So generally on the left-hand side of our periodic table, that is mostly metals except for hydrogen. As far as our metalloids, we pretty much treat the ones that are on the metal side like metals and treat the ones that are on the non-metal side like they're nonmetals. These are going to have positive charges, and we've already gone into detail in previous units about why they have that charge. And then the other side is going to be a nonmetal, which is going to be your negative charge. And on your periodic table, something that you have that we haven't really addressed yet are these things that are called polyatomic ions. Notice that they're mostly negative ones that are listed, but we also do have some positives. These are like clumps of atoms together that overall have either a negative or positive charge, so I included them for you. Ionic bonding can also occur between those things, so it doesn't have to be just a single metal and a single nonmetal. It can include something like a polyatomic ion as well. So we're going to write over here that it's at least going to be between a cation or positive ion and an anion. Negative. Every time that we write these, I'm writing them in the same order on purpose because your cation will always come first, your metal is always going to be listed first, and then your nonmetal comes second or your anion comes second. That will stay consistent every single time, so as we learn about formula writing, keep that in mind. And then letter B says the metal, which is your positive ion, will lose its electron, or it loses its electrons to the nonmetal, which is your negative ion. And the number of electrons lost must equal the number of electrons gained.